Hello and welcome to today's online training on Nios V processors hardware integration. Feel free to pause, move forward or go back as you need during the presentation. You can find the control bar at the bottom of the course screen. You will find resources and links that are related to today's training in the section at the top right. On the left, you will find the outline for the slides. Feel free to navigate them as you need. Let's get started. The Intel FPGA portfolio supports this transformation, including discrete and integrated FPGAs that are expected to improve processing efficiency, task specificity, and connectivity. Intel FPGAs can provide a variety of workloads in network processing as well as compute and storage acceleration. FPGAs are mass-produced, standard product ICs that can be reconfigured in the field to accelerate virtually any digital algorithm. They offer greater throughput, execution speed, and energy efficiency than CPUs on computationally intensive parts of algorithms, but with the ability to adapt quickly to changes in algorithms, data patterns, or performance needs. They can be reconfigured in the field to accelerate virtually any digital algorithm. They are available in 5 current families: MAX, Cyclone, Aria, Stratix and the newest family Agilix, all with of increasing capacity, performance, and feature sets. The course agenda for today includes Nios V processor hardware design flow, adding Nios V-M and Nios V-G processors in Platform Designer, and Nios V-G custom instructions. The objective for today's online training is to create a Nios V processor hardware system design with Intel Quartus Prime software and Platform Designer to use with Intel FPGAs. Let's get started. Nios V processors are Intel's next-generation soft-core processors based on the open-source RISC-V instruction set, designed for Intel FPGA devices with support in the Intel Quartus Prime Software Pro and Standard editions. There are currently 3 versions available for Nios V supported with different applications. Nios V-M processor with microcontroller suggested use. Nios V-G processor as a general-purpose processor with custom instructions and Nios V-C processor the compact microcontroller. Intel FPGA IP-based embedded processor can behave like a discrete microprocessor-based system for which 2 elements are necessary. JTAG interface to configure, for hardware and software debug. Power up Intel FPGA's configuration mechanism. Intel FPGAs contain no logic when powered up. Before using a Nios V processor IP-based design, the device must be configured with a hardware design that contains a Nios V processor, which can be placed anywhere on the FPGA. Some of the advantages of Nios V processors include RISC-V open community and huge ecosystem and support, wide ranges of operating systems supported, no need to install WSL. Ashling RISC-free IDE for Intel FPGAs supports different capabilities for debug and software build bundled in supported Intel Quartus versions. To know more about Ashling RISC-free IDE for Intel FPGAs, you can read our user guide in the link provided in the resources. You can visit Intel.com and search for available resources related to Nios V processors, as well as user guides, design examples, support and documents that will help you through your design creation. You can find more details about the discontinuation notice in our website for Nios 2. This applies for upcoming devices and Intel Quartus Prime software newer versions. If you want to know more, go to the link provided to the document about the discontinuing IP. You can also look at the document on processor migration guide to migrate to the corresponding Nios V core provided in the resources section. This is the list of functional units that both Nios V-M and Nios V-G have as part of their architecture. Additional to the previous units mentioned, These are some features for Nios 5G processor. On the right, you see highlighted the differences for Nios 5G processor core. Remember that the Nios 5G processor is a general-purpose processor that has custom instruction logic, instruction cache, data cache, and a multiply and divide unit. Nios 5M processor core, which is a microcontroller, has the architecture shown on the left: program controller and address generation, exception controller, ALU, general-purpose registers, control and status registers, as well as a load and store unit, a timer and software interrupt module. Notice in red the debug options. The option with Nios 5C being a compact microcontroller is the small Nios 5 version with non-interrupt driven control application. The Nios 5C has the following functional units: arithmetic logic unit, general purpose register file, instruction bus, data bus, and ECC module. To get started with your designs, you will need to install a version of Intel Quartus Prime Pro Edition 21.3 or later, or you can also have the standard edition 22.1 or later. Additional to Intel Quartus Prime software, you must have the device support installed that is compatible with Nios 5. Ashling RISC-free IDE for Intel FPGAs is necessary for software design with Nios 5, as well as the Nios 5 shell, both provided with installation for Intel Quartus Prime software. You can go to the Self-Licensing Center to obtain the Nios 5 processor's license files to compile your design. Intel recommends installing the same software version for all of the elements described. This is the flow diagram for Nios 5 processor system design. Notice that as part of the flow you can find hardware and software flows. For today's training, we will cover the hardware flow using Intel Quartus Prime software and the tools in Platform Designer. To compile the whole design with time constraints and pins assignments, you will be using the project created in Intel Quartus Prime software. Then you can use Programmer inside Intel Quartus with the target board. You can download different versions for Intel Quartus Prime software from our website. You can also look for device support guides and additional software. There are 3 editions for Intel Quartus Prime software available. For Nios 5 processor design, only Standard and Pro Edition are supported. For the software development, you need to install Ashling RISC-free IDE for Intel FPGAs, which is now embedded in the Intel Quartus Prime software installation, or you can also install it as a standalone version. This is for building the project and debugging your application through JTAG. If you want to get started with a Nios 5 example, you can go to Intel.com and search for the design store. There you will find examples on Nios 5M and Nios 5G that can help you get started and become familiar with Nios 5 processors. You can also look for your development kit examples from inside Intel Quartus Prime software in example projects in the main screen, and look for Nios 5 examples targeting your development kit. Nios 5 processor support varies depending on the Intel Quartus Prime edition and version. For Intel Quartus Prime Standard Edition software, only Nios 5M is supported. For Pro Edition software, both IP are supported. Device support is important also to understand your design needs and capabilities when developing with Nios 5 processors. On the software development side, you will need to invoke the BSP editor in different ways on each edition. We will now walk through how to use the tools inside Intel Quartus Prime. This walkthrough goes through the steps for Intel Quartus Prime Pro Edition, since it will show how to use Nios 5 processors. Start by opening an Intel Quartus project and then go to Platform Designer in the Tools menu. This will open an existing QSys design, or you can create a new one. Then you can import from the IP catalog the Nios 5 processor you will use for your design. In the option Platform Designer System, you can open an existing file by pressing the button with 3 dots, or you can create a new one by pressing on the button on the right. Notice that the settings for the project, board and device family have already been filled out, since these settings can be taken from the Intel Quartus Prime project. On the left of the main window in Platform Designer, you will find the IP catalog. As you begin typing Nios V, you will notice that the list for the available IP will appear. Once you double-click to add the Nios V component, the window for configuring the device will appear. You have also several options inside Platform Designer capabilities, such as the Show Signals option to expand the block diagram. In the case of Nios V-M, you can configure in this window debug settings, reset request, vectors like reset agent, reset offset, exception agent, and exception offset. In the parameters window, you have different options to configure Nios V-M. As mentioned before, these options are enable debug. The connection provides the following basic capabilities: start and stop the Nios V processor, examine and edit registers and memory. Download the Nios V application.elf file to the processor memory at runtime via Nios V download. Debug the application running on the Nios V processor. Enable reset from debug module. You must connect the DBG resetout interface to NDM reset in instead of reset interface to trigger reset to the processor core and timer module. Add reset request interface. The reset interface consists of an input resetrec signal and an output ACK signal. You can request a reset to the Nios V processor core by asserting the resetrec signal. The resetrec signal must remain asserted until the processor asserts a CK signal. The Nios V processor responds that the reset is successful by asserting the ACK signal. Reset agent. You can select any memory module connected to the Nios V processor instruction master and supported by a Nios V processor boot flow as the reset agent. Reset offset. As shared in the slide, Platform Designer automatically provides a default value for the reset offset. The option to use custom instructions is available with Nios V-G. To use Nios V-G processor IP with custom instructions, the same steps must be followed to add the processor. Additional configuration for Nios V-G appears for processor caches and peripheral regions. The options to add custom instructions and software C macro table appear in the parameters configuration. As you can see in this parameter description table, all these values are to configure caches and peripheral regions with sizes and their alignment to region sizes. Peripheral region A size. Note: you can use peripheral regions to define a non-cacheable transaction for peripherals such as UART, PIODMA and others. In a Nios V-G processor system with cache enabled, you must place these peripherals within a peripheral region. In the Nios V custom instruction hardware interface table, you can define up to a total of 32 individual custom instruction manager interfaces. The Nios V custom instruction software macro table. In here, mnemonics may be used to define custom names for the generated C macros in the system H file, the generated GDB debug mnemonics in custom instruction debug.xml file. For each defined custom instruction software encoding, the opcode custom 0 to 3 and 3 bits of funct7, 6 to 4 encoding must correlate to a defined custom instruction manager interface encoding in the custom instruction hardware interface table. Implementing custom instructions involves using the custom instruction tool flow and comprises of the following tasks: writing the custom instruction HDL file, specifying the custom instruction component type with the component editor, displaying the custom instruction block symbol, adding the HDL files, configuring the custom instruction parameter type, setting up the custom instruction interfaces, saving and adding the custom instruction, and generating the system and compiling in the Intel Quartus Prime software. To open the component editor, you can go to File menu in the main Platform Designer window. Then open the New Component option. Start by modifying the name, group and description as needed for this component. In the Block Symbol tab you can preview and edit the HDL file block symbols. Then in the next tab named Files, you will find options to add the HDL file created for the custom instructions. Then press Analyze HDL files to finish editing this section. The Parameters tab allows preview of the component GUI and to select or disable the parameters in the component. In this tab, change all signals type to Nios V custom instruction subordinate. Include the clock input and reset input under the Nios V custom instruction subordinate. Match each HDL signal to the appropriate signal type. The elements configured in the parameters for Nios 5G appear now in the system view as Nios V Custom Instruction Manager. These need to be connected in the design. After pressing on the Generate HDL button when your design is ready, a generation window will appear where you can choose several options to generate your HDL files. For the case of Nios 5C integration to the system design, the process is the same, through the IP catalog. The version that supports Nios 5C is Intel Quartus Prime Pro version 23.3. Intel Quartus software includes with the installation Nios 5 command shell. You can do several tasks through this tool for the whole design flow. The flow to generate a file for the FPGA are parts that can be customized by the user. It is important to note that before programming the FPGA there are steps to be done during the software flow that happen in between BSP generation and full compilation, like hex file generation or CMake creation for software development. To integrate the design to an Intel Quartus project you can instantiate the Nios 5 processor system module into Intel Quartus Prime project through the top file or through a block in the .bdf file. Connect any signals external to the FPGA in the top-level file in the Intel Quartus project. Assign pin and signals for your Intel FPGA with pin connecting tools. Constraining Intel FPGA design. The top bar for Intel Quartus Prime software has a button to start compilation, as well as options to compile your project and the compilation dashboard with the results of each stage of this process. Once the project compilation is done, you can use the Intel Quartus programmer to download the design to the board. You can find the programmer in the Tools menu as well. During compilation, the SOF file is generated, which is used to program the FPGA. There are several embedded development tools that are available in the Nios 5 processor landing page, which include reference manuals, user guides, tutorials and videos, to get started setting up your development environment and designs. Intel provides multiple avenues in which to learn about Intel FPGA products. There is the Intel FPGA YouTube channel, which contains 5-minute quick videos along with longer, more in-depth training videos. There is the Intel FPGA training website, where you can access e-learning courses made up of narrated slides presented in an interactive player, some courses with labs and demos. Lastly, you can also enroll in a live, instructor-led course presented either in person at an office local to you, or virtually over the web. All instructor-led courses have hands-on labs exercises to practice the concepts you learn. If you need more assistance, Intel FPGA provides many self-help resources for you to access. For example, there are web pages, called landing pages, dedicated to specific FPGA technology like high-speed interfaces. You can also view and post questions to the community forum, which is monitored by skilled Intel FPGA applications engineers. The Intel FPGA training team is always looking to improve our material and welcome any feedback you may have. Please email fpgatraining@intel.com with any of your thoughts or comments.